Part 3 of Module 1. In this video we're going to be talking about Objective 1A. It's an introduction to arithmetic and geometric series. We're going to, Part 3 discusses series and summation notation, but we're going to get into summation and notation in later videos. Part 3 has 3 objectives, so be considering that. This is the first objective, just the introduction to what a series is. So, to begin, a series is the sum of the terms in a sequence. Before this, we've just been working with sequences themselves, numbers that fall in line, and then we've been trying to find if there's a common difference or a common ratio, and that determines if this is arithmetic or geometric. In this case, this sequence that is given to us, 3, 6, 9, 12, all the way to 27, hopefully by now you can visualize that there is a difference that is in common of 3 each time. It's being added by 3 each time. So this would be an arithmetic sequence with a common difference of 3. That's just review, but hopefully by now your brain is able to see that. Now, the sum comes into play hugely, and we're going to talk about the formulas for arithmetic and geometric in just a minute. Because if there's situations where, let's say you do want to find a sum of a large pattern of numbers, before these formulas were existed or created, you actually had to do it by hand, where you would sit and do 3 plus 6 plus 9 plus 12 plus 15 plus 18 plus 21 plus 24 plus 27. You just do that by hand. This one's short enough, so you can go ahead and do that if you want to. The sum is 135. So series notation is noted. If you've recognized, sequences are usually written as separated by commas, 3, 6, 9, 12. A series, sequences are up there. A series is denoted by addition in between. I just drew a series, or finished out that series right there. And so you could do it longhand, but there's a lot of reasons why that would be just too much work, and that's why these formulas, explicit, or not explicit, just the arithmetic series formulas were created. For instance, and we're going to talk about this hopefully later on, just discussing real world problems with this, but let's say you have $100 and you pay yourself $1, or even let's say you start with $1, but you add $1 each time to what you're giving to yourself, so it goes 1, 2, 3, 4, 5, 6, all the way for a year. And instead of adding up all the numbers in that sequence 365 times, you can use these types of formulas to find out the sum in a very quick way. That's why they were created. They're working with engineering and that type as well. But for series, in the series formulas, what we're getting into and what we need to know, that are very important. It's important, just like the explicit in formulas for finding specific terms in a sequence. These are important for finding the total sum of a sequence. We're going to deal with 2, arithmetic and geometric, just like we did for earlier parts. Arithmetic series, the formula is n, so the term number, times a sub 1, which is the first term in the sequence, plus a sub n, all over 2. Pretty straightforward. The geometric is a little bit more complicated than that. It's a sub 1, the first term, times 1 minus r raised to the n, all in parentheses, all over parentheses 1 minus r. Those are the 2 formulas. Those are the 2 formulas we'll be working with for a lot of the practice after this video. So, because these formulas are so great and they save us a lot of time, there are a few steps that we need to take in order to use these formulas to actually solve and evaluate a series within the terms. In example 1 you see down there. So the steps to use these, for evaluating a series using these formulas, you have to determine a few things. Determine first if the sequences are arithmetic or geometric. Hopefully that skill is pretty straightforward to you by now. Geometric. The second step is once you do that, you input the data that is necessary, or the information necessary you're given, into the appropriate formula. So really you just have to determine is the sequence arithmetic or geometric, because that clues you into, should I use this formula or should I use this formula? Alright, if you notice, really for these formulas now, everything changes. Where before the explicit formulas, only a couple things change, these n, a sub 1, a sub n will all change. A sub 1, r, and n for geometric will all change. But we're going to get into doing example 1 in the next video. That was just a little bit of information about what a series is and the things you need to be able to identify in order to successfully find the sum of a series if given specific information.